Hey guys, so today we're going to look at radicals. Radicals are square roots that, for example, like the square root of 24, that are not perfect squares. They represent irrational numbers. If you put this in the calculator, it'll be a decimal that goes on forever without any repetition. This is an irrational number. So what we do is we simplify radicals, and we do that by removing any perfect squares that are factors. Remove perfect square factors. So for example, in the number 24, if you think about perfect squares, 1, 4, 9, 16, 25, 49, etc., right? 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 7 times 7 is 49. Those are all perfect squares. A perfect square that goes into 24, well, 1 we're not going to count for anything because 1 goes into everything, but 4 goes in. So we break this up into the square root of, this is 4 times 6. So you would not say 2 times 12, because 2 and 12 are not perfect squares, but I would break this up into the square root of 4 times 6. And since the square root of 4 is 2, I put that on the outside. 2 is rational. But what's left, the square root of 6, is irrational. So we simplify this as 2 times the square root of 6. That is equal to the square root of 24, but it's been simplified. Just like you would simplify a fraction to lowest terms, you're simplifying a radical. Okay, so here's another example. The square root of 48. So when I think about breaking up the square root of 48, I think of, well, hold on one second. Let me scroll. Oh, I can't scroll down. Square root of 48, there's a couple of perfect squares that you could think of that goes in. So like 4 goes in, right? Square root of 4 times 12 is 48. But what you're going to see is that there's a bigger perfect square that goes in. 16 times 3 is 48. So you could do either or, but it's always faster to do the bigger perfect square that goes in. So 16, square root of 16 is 4. That comes out, because it's rational, 4 times the square root of 3. Now, if you had picked 4 times 12, then you'd basically have to simplify twice. So the square root of 4 is 2. 2 comes out, and then you have to see that, oh, well, 12 still contains a perfect square factor, 4. Since that can break down into the square root of 4 times 3, you take the square root of 4, then multiply it by the 2 on the outside, and you end up with the same final answer. It's just like reducing a fraction, that sometimes you have to reduce a fraction twice if you didn't find the biggest factor. Okay? If you see something like this, 81 is a perfect square. So that would just be 9. That you wouldn't need to simplify with a radical in your answer. It would just be a rational number 9. Okay? Here's another one, the square root of 54. I'm having trouble scrolling down on this thing. Square root of 54. So think of perfect squares that go in. So 6 times 9 is 54, and 9 is a perfect square. So that would work nicely. Square root of 9 is 3. 3 times the square root of 6. Here's another one, square root of 60. So immediately 6 times 10 comes to mind, but I don't want 6 times 10 because 6 and 10 are not perfect squares. So instead, I'll use 4 times 12. Or, even bigger than that, sorry, hold on, not 4 times 12. One second. 4 times 15 is what I meant to say. So the square root of 4 is 2. 2 times the square root of 15. All right, so we have a couple of these to do for Thursday. Do Thursday. And just always keep in mind the list of perfect squares in your mind. Starting with 1, but we don't count 1, 4, 9, 16, 25, 49, 64, etc., etc., etc. Okay? And I will see you guys on Thursday. Thanks.